Hello everyone, my name is Vihan and today I'm going to be making a robot using the Lego Education Spike Prime Kit. To start off, today I'm going to be making a hopper. A hopper is a sort of robot that moves, but instead of wheels, it's got two arms that it uses to drag itself across the ground. To start, get the smart hub and put in the battery. If the battery doesn't go in the first time, turn it the other way around and then try. Now we shall be putting the legs or the arms of the hopper together to the body, which is the smart hub. Place 3 connector pegs like so. Make sure that these 2 connector pegs at the top are facing and are on the same direction as the charging port and the top of the smart hub. Now connect the motors like so. If you find it's not working, like mine, remove the connector peg and make sure that it is here and not here. Because if it's here, it will be too much area for the medium motor to cover. Now you should be able to connect the motor to the smart hub. Your model should now look like this. I will be doing the same thing for the other side. Remember, it should be symmetrical like this. There will be one connector peg here, here, and one on here. So it should be a mirror image on this side. Now we will connect the medium motor. With the 2 medium motors in place, now you must check if the motors are in reset position. This means that this on the spinning part of the motor, this gray part, should be aligned with the circle. Check this on both of the motors. Now the front part of your model will look like this, and from top it will look like this. Now we shall make the legs of the hopper. Now we will be making the arms of the hopper. For this, we will need this angular beam. This beam is a 6 by 4 by 3 angular J beam. We'll need one of this, an axle connector peg, and a 2 module connector peg. I will be connecting the connector peg in the top hole of one of the motors. Then I will be connecting the axle beam, the axle connector peg, in the bottom hole. I will be doing the same for the other side. Now I will connect the J-beam. I'll start by putting the connector peg over here and the axle beam at the bottom. Now it goes in. I will be doing the same for the other side. So now this is what it looks like. So now you can get an idea of how the hopper will work. The motors will go and it will push and go like this. So if you check it, it will be something like this. Or another idea that comes is that it will go like this. Now I have reset it, and now we will be doing something else. If the hopper goes like this, then the beams have a chance of getting broken or damaged in any other way. So now we will be putting protection for it. We can use this ball connector peg, or the solution that I'm going to use now are these. In the gear compartment, you can find these rubber axle holders. So we will be getting an axle out. This is going to be a 3-module axle. So if you put it besides a beam, it will be 3 holes tall. 1 hole is equal to 1 axle, so I know that this axle is 3 modules tall. I will push this one down to avoid confusion. As you can see, I'm putting this axle inside through this hole. Now I will put this rubber gear here and another on this side. Now when the hopper moves, this will protect the beams, at least the tip of it. Now I will push this one back and do the same thing that we did for this one on this one. This is another 3-module beam. A way to identify that a beam is a 3-module beam is to see the color. There will be 3-module beams, 7-module beams, and 11-module ones that are yellow. So you know that the smallest yellow axle is a 3-module axle. Now I have finished putting the rubber onto the axles. Now I have also reset the motors. So that's done. So right now this hopper looks a little strange. So we're gonna give him some eyes. Giving robots eyes is pretty easy. From the first compartment, you will find this. Now, I'm going to get an axle connector peg and connect it from the bottom. So now this is how it looks like. Now on top of this, I will be attaching this. Right now it still doesn't entirely look like eyes. So I'm going to search for these eyes and put it on top of this. So it should look like this. Now our robot needs to have 2 eyes. So I will be doing the same for the other eye. So here I have both the eyes, and if you want just one eye, you can put a beam over here with 2 connector pegs and then put one eye right in the center here. But mine needs to have 2. So I'm going to be putting one eye over here and the other on the mirror side. Now since the axle pegs are frictionless, your eyes will be moving around. But that's okay. Now for these wires that are just rolling around, I will connect the first wire, the right wire in the B port and the left wire in port A. Still looks a bit messy. I'm not gonna hold it by the wires. So I'm going to be taking 2 of these. These pegs, axle pegs, are really coming in handy today. I am going to take 2 of these. These strange colored objects are wire clippers. You can use them to clip wires and stop the wires from looking messy. So I think we can replace these 2 with a 2-module axle. A 2-module axle is the only axle that's red, so I think it should be easy to recognize. Just to keep the pattern, I'll take the red wire clippers as well. Now that I've connected the wire clippers with the axle peg, I'm going to connect the wires together. Now they are connected to the wires. This is so that the wires don't get stuck on the ground or subject to damage. If you want your thing to look still neater, you can do it in a different way. Take 2 wire clippers and put an axle peg into this. Now I am connecting this at the back here. You can connect it where you want. Some would prefer to put it here on the side. Some would even prefer to put it in front to avoid it getting stuck. Many would actually prefer putting the 2 wire pegs, 2 wire clippers for 1 wire. I'm going to go with that technique. So now I put 2 wire clippers here. And now I think I'm going to put the other wire clippers here. After all that, I thought I'll just skip it. Now since this, it's still going on to the sides. So I am going to hold it and pull the wires to the back. So now there will be equal wires, equal part of the wire on both the sides, back side and on the left and right side. So in the end, this is my hopper. So I checked a few glitches and I found that while doing decoding, the arms weren't quite able to move completely. So what I'm going to be doing is I will disconnect the wires. So the wires were obstructing the arms from moving. So I thought I'll move the arms a little away from the wires and the body of the hopper. So I thought I removed the arms, you can see, and I thought what can we alternate instead of these connectors. So I checked the box and I found some things that we could use. So I'll show you what. So the error came here. Over here, this and this needed to be extended so they won't hit the wires when the wires are like this. So when the wires are like this, the arms will hit it. So what I did was, I disconnected the wire and I replaced these. I'll show you what that is. You'll find this in the same compartment as this and this. So I put that on top here instead of the connector peg. And down I put something called a 3-module axle. It's actually called a 3-module axle peg because this is an axle connector peg, as you know, but this has got 2 modules of it are axle and this one module is a connector peg. So I put that at the bottom here. And then I put this strange little thing over here. So now I got to connect this like so over here. So now that's how I put it. And now I'm going to do the same thing for the other side. So gonna put the arm like so, and done. And this way now, even if the wires are connected like this, the wire clippers will clip them like this, and this will go on top like this. And when the arm goes backwards, because of the extension, it won't hit the wires. Now this means that this was variation 2, but the variation that we're gonna use has a repeat block. This repeat block will repeat whatever is in it until the timer is equal to 8. Hello everyone, today I have created a new project and I think we can start coding the hopper now. I have named it hopper, so now I can know that this is the project for the hopper. So you can see the hopper. I have connected using USB. Do I need to connect it to using Bluetooth in a few moments when I need to start the code? But now let's start. I have in events, as you can see. I'm taking a when program starts block and placing it here. My motor is going a bit crazy on the position, but I'll forget that for now. Now there are 2 ways we can go about, but both of them start with this block. Actually this one. A goes shortest path to position 0. We're gonna take this here. I'm going to click multiple and then click on B. So now both A and B motors will go shortest path to position 0 when we click on the play button. So now that would mean if I were to play the program, so to play the program we'll need to connect to the hub, and okay, this is only working using the USB. So I'm going to connect to the USB for this, but later I'll need to connect to Bluetooth. So I am going to connect. If you're using the web app, you'll see this option. I've connected to USB, back to project, and now if you can see this is the hopper, and I am going to move this arm up, and now I am playing the project. The project moved it to position 0. Now I'm moving this like this. So now the arms are in different directions. One is upwards, one is downwards. Now I've clicked on play. They both move back to position 0. One moved clockwise and the other anti-clockwise. Why? Because it goes to the shortest path. If we were to make this into clockwise or anti-clockwise here, both the arms would go only in that direction, back to the start, position 0. Even if it's already at position 0, it'll move. We could use movement, but I'm using motors for it is easier. From here we can take two approaches. We need to make a timer, or we can make it go forever. If we put forever, it'll go on walking forever. But I want it to stop after some time. So I'm going to keep the forever here. So now I have put a run anti-clockwise for 360 degrees. I have taken this block and made this anti-clockwise and made this 360 and this into degrees. So we'll make one full turn and then it will wait 1 second. B is going to do the same thing. So if I start this program, B is going a bit haywire, so I'm going to change B into the other direction. So now that's working. The other few variations will be quite the same. Instead of timer over here, or even repeat until, we can put something else. We can just make this into a forever loop. Or for a third variation, I'm going to duplicate this. I will make a variable called timer, and this variable will work exactly the same as this. So here we will be setting timer to 0 instead of reset timer, and we will also be putting another when program starts. We're going to be putting a forever here, but this is still part of the third variation. In this variation, the timer will always be changing by 1 from the time the program starts. So this means it'll manipulate the timer that's actually there. So this comes under variation 3. So now this is variation 3. This is variation 2. This is variation 1. And this repeat until is also variation 3. Now, how does this work? Just a minor change in variation 3 to avoid any glitches. So, I have connected my hub again. I have connected it using Bluetooth because I will not be able to connect the wire. So, my hub is on. And I can see this connect button. I have named this is not a port number, I've actually named it 1.18.12.2. So now this will be the hub that I will be connected to. I'm going to do back to project, and now you'll see this option. I switched to the app and I am using the timer variation, the variation 3. So I'm going to download this. I'm going to click on this 0, clicking on download, and I want this to be in storage position 0, and I'm going to click on download. The thing about downloading your project into your Smart Hub is, if you don't have time to switch on your computer, open the Lego Education Spike, find the project and then run it, you can just remember the number and then do it. So now on my Spike Hub, I am going to open this. I'm going to click on the side button, and now it's in position 0. So if I click this button, it will start. So this is the hopper. I am going to test it. apparently it's working. So if you see, it'll go like this and then like this and like this, but don't worry, it'll still go in a straight line. So let's try that again. Let's see how far we can go in 8 seconds. Okay, not bad. So that is the hopper for you. Thank you.